I'm Alex. I will tell you about grouping and aggregation in Postgres and how to optimize it. Just a little disclaimer, what we will and what we won't consider today. We'll consider grouping and aggregation, and we will not discuss retrieving the data, filtering, joining, as well as window functions, because they are not aggregating. In fact, they do not narrow the result set. They do not shrink the data. Contents. First, we will determine and define what is grouping and what is not. On the second part, we will learn the internals, how do aggregate functions behave, how are they structured inside, and how Postgres groups and aggregates data, what algorithms are used. The third part, the main part, is optimization. First, we will avoid sorts. Sorts are slow, how to avoid them. How to summate properly. How to aggregate denormalized data. Sometimes we have to deal with denormalized data, though it's agile. And how to perform an operation named ArgMax. And as a bonus track, what to do if it is still slow. What is a grouping? We call an operation a grouping and aggregation if it is an operation of dividing our result set, our input set, to several classes, and compilation of each class into a single row. This is how summation works. Examples in SQL. Straightforward example with group by keyword and aggregate function invoked. Distinct operation is also a grouping. Simply the aggregation function is trivial, but it can be rewritten as group by button ID. It's just the same. This is a PostgreSQL specific syntax. It is used to order the data and to take the first row of the siblings. It is non-standard. Single group operations are also considered, even if they are written not using group by or aggregate function syntax. How does it work internally? An aggregate function comprises a type of its state value and two functions, transition function and final function. At the very beginning, a state variable is initialized by initCount by some value, and on every row, every input row, we call asFunc, the transition function. It accepts a state variable as an argument and an input value as a second argument, and it returns us the next state value. And final value of state variable is converted to the result using final function. Some examples. This is how summation works. Initial state is 0. Transition function is plus operator. Final function is trivial. One more sophisticated example, average function. State variable type is a composite type, two numbers, count and sum. On every step, we increment counter and we add input value to the sum. And final function is division. We divide sum by count and get the result. Those functions are ordinary functions, ordinary stored procedures. They can be written in any language that is supported by PostgreSQL. The preferable is C, because it's fast, not only because it's low level, but also because the transition function can reuse the previous state value to compute the next one without copying, without allocating new memory. Most of all, for training purposes, for experiments, you can write it in SQL and PL2GSQL. I don't know what happens if you try to write it in PL Python, PL Java, or PL Brainfuck. There is such a language. Important note is that these functions can be declared as strict. They can be not called on null values, so null values could be skipped, and this is a massive boost up for the performance. They don't, null values can skip participation in all this schema if the function is declared as strict. This was about aggregation functions, and this is how group by works. Postgres has two algorithms, group aggregate and hash aggregate. Group aggregate accepts previously sorted data, and it computes the values for the groups one by one. And hash aggregate uses a hash table to store the states of several aggregate functions running in parallel. This is how it works. This is group aggregate. Input set is already sorted by color. We are grouping by color, and the state value is 0. This is the aggregate function has consumed two values. This is the aggregate function already produced one result for the blue ones and started to consume the green ones. The green ones are also produced. And finally, we get the result. This is summation, as you could guess. Hash aggregate behaves another way. The input set is not sorted. And for every color, we use different state values. So those functions work in parallel. Not in terms of CPU usage. It's one core as usual for PostgreSQL queries. But they are produced not one by one, but in the same time, the state values are kept. And here's the final func. It works at the very end. It applies to all the state values. What are the pros and the cons? Group aggregate requires sorted data. It's a bold minus for it. But the cons are group aggregate needs less memory. It needs to store only one state variable at a time. It returns sorted data. It starts returning data earlier than all the process is done. It returns data even earlier than it got all the input data. And it can perform sophisticated aggregate function calls using distinct or order by keywords. Quite the opposite, hash aggregate accepts unsorted data, and it is its main plus. It needs more memory, returns unsorted data at the very end, and perform only basic aggregation. How to optimize all this stuff? Sorts are really slow. You should prefer hash aggregate if you can. You see, you may be in luck and your group aggregate may get already sorted results from somewhere. I don't know, maybe from index search, but not bitmap index search. Maybe from some merge join, but usually the data is retrieved by sexscan, sequential scan, I mean, or from bitmap scan, and it comes unsorted. What to do if you get something like this? You run an ordinary group by. Your explain shows you that you will use sort and group aggregate, and it works for 1.5 seconds. Common approach is to blame planner, to say, you stupid planner chose the wrong plan. Let's force, let's hint you, let's avoid sorts by setting enable sort to off. This doesn't work. You will get very large cost values and still the same plan. The clue is you need to increase work mem. Your PostgreSQL was configured with little work mem, and your hash table for the state values could not fit the memory. That's why the planner chose the group aggregate plan. Here we increase work memory, and the query uses hash aggregate. It's much faster, but don't increase OOM too much. Consult your DBA, or if it happens you're a DBA, then have a look at your max connections and your memory size on your box. You see this work mem is for one operation. So if your query has 3 joins and 5 groupings, then it can consume 8 times more memory than your work mem parameter. It's not per client, not per query, it's per operation. How to spend less memory to allow hash aggregation and to save the memory? The interesting idea is don't aggregate join, join aggregated instead. It helps both joining and aggregation. Joining works better because they will have already aggregated small set, and aggregation will work better because it will not have to store excessive columns. Sometimes we have to support the operations that cannot be performed using hash aggregate, sorry. Say count distinct. And we will have to sort. Here we have to sort on this because the data is large. 10 seconds. The solution is to use 2 levels of hash aggregate instead of 1 level of group aggregate. First, we take distinct keys and values, and second, we get distinct keys and number of values in the distinct set. Much faster. 2.5 seconds. Same for order by. Some aggregate functions, their result could depend on the order of input values. Array AGG is the example. You can sort them afterwards. You can aggregate them in any order, and in the outer query, sort only the results. You see, sorting is a non-linear operation. It is analog n, so it is cheaper to sort several small arrays than one large. And here we can use hash aggregate for aggregation. The next section is how to summate properly. PostgreSQL has three types for integer values: int, begin, and numeric. And it's interesting that there are 3 sum functions for them, and the return type is not the same as the input type. It seems to me it's done for avoiding overflow. The most strange is the begin function. It returns numeric, and it is very slow because internally it converts each value from begin to numeric. This operation is expensive because numeric value is much like varchar. It's variable size, it stores digits, and begin is like internal, like machine value. So if you have problems with summating begins, just convert them to numeric in the table. Or maybe you will need to write a custom aggregate function. But numerics are also sometimes shorter on disk, especially when there are zeros. This is how to deal with zero values. If you are going to calculate the total number of cats over all the cities have cats, everyone likes cats. If you have few zeros, then you will use a straightforward solution. It's the best. But if you calculate number of tigers, most of them are zeros. So it's better to filter them out. Even in case of numeric, even using null leaf function, if you cannot filter for some reason, could benefit. But the best is just to convert all zeros to nulls in the table. It breaks null semantics, but it increases speed and decreases the consumed space on disk dramatically. Next section is denormalized data aggregations. Sometimes you have denormalized data, either intentionally or by historical reasons. Sometimes you have to aggregate it. Say here we have account ID, account name, and we need to summate the payments. Account name is the same for every ID. By the way, Planner does not know that account ID and account name correlate, and it thinks that they are independent, and it thinks there are quadratically more groups, and it could choose sort, not hash aggregate, just for this reason. A bit less known approach than the straightforward solution is to use some aggregate function that does preserve the same value, say mean. Luckily, we have mean function for strings. For some types, we don't have mean or max functions. We can write a custom aggregate function in SQL for now. The function named first simply returns its first argument. It's supposed to be our transition function. And the final function is trivial. And we construct the aggregate function named A and use it. We can write the same in C. The code should be very large. Thus, I will not present it. Let's compare the speed of this stuff. C function wins dramatically. This is the length of account name. Interesting that for the very long denormalized payload, it could be even faster, because those values are not even decompressed from toast. So it's faster for 10,000 than for 1,000 character values. The next story is about ArgMaximum. What can maximum do? Maximum can show you population of the largest city in the country, in each country. Date of last tweet by each author, the highest salary in each department. It's very interesting, but the most interesting is what is the largest city in each country? What is the last tweet by each author? And who gets the highest salary in each department? We call this operation ArgMax. Max is built in. How to perform ArgMax? It's a common question for interviews. They suggest us using self joins, window function, and so on, depending on restrictions of SQL subsets. Postgres suggests using distinct on. This is exactly what we would like. But it's slow because it needs sorting. We can emulate ArgMax using dirty hacks. We compress the key and the value into one array. We take maximum of one array. It's sorted firstly by the first element of the array, and after all, we take the second argument, the second item from array. It's not very beautiful, especially because we have to convert date to integer, and it is not always possible, I think. to convert two types to the one with sort result. It's time to write more custom aggregate functions. For this function, the type of the state is a composite value. It stores the would-be maximum and the would-be key for the maximum. And on each step, if we get the new input value more, then we replace the state. If less, then we preserve the state, either the key and the value. In final function, we just return the payload, ignoring the key we stored by. Surely, it is to be written in C as well. And here are the benchmarks. The values on the first row are the number of tweeters and number of tweets per tweeter. C function wins, but if you have enough space on 1 billion rows or something like this SQL function works better because it has better asymptotics. It's a common situation. C functions and SQL functions have the same asymptotics, but SQL or PostgreSQL functions have very bad constants. So they work properly on very large sets. Writing those functions in SQL or PostgreSQL is faster, and it could be used to prove the concept, prove that your idea works. And then if it works, you can optimize it using C function. What to do if your grouping or aggregation is still slow? You will have to apply dirty magic. Sometimes, yeah, when you are computing max, ArgMax, or distinct, or something like this, you will not have to load all the data. If you have an index, you can grab the first value by index, then grab the second value, grab the second is the one that's more than the first, then grab the next, and all the values. So you can write a procedure instead of a query, a loop inside, and take the values one by one, return them one by one. You can use pure SQL, it is a bit faster. You can use recursive queries. It's just the same, but not so readable. And a bit faster. So this approach is incredibly fast, unless it returns too many rows, like in the leftmost column. But it needs an index that needs to be maintained. It slows down the insert, just as usual. And it needs some tricks, the SQL approach, if the data type differs. Not so dirty as the previous solution, just wrapping them into some custom typing. And this is the overall benchmarks for several solutions for ArgMax. What to do if your hash aggregation is still slow? There is an additional module for PostgreSQL 9.5 that supports parallel aggregation. No magic. It loads several of your CPU cores, and it is most useful for complex operations, like if you use case when or some other functions inside your sum or inside your max operator. It speeds up sequential scan as well. There are at least two known approaches to speed up count distinct. The first is hyperlog. It's a recently developed algorithm for approximate for approximation of distinct values. It uses constant memory, only one run, and quite reliable. Its reliability can be tuned using number of used memory, and it is implemented. It's implemented in as a PostgreSQL extension as well. Another idea is to use statistics. Statistic is what you are seeing in explain. When you do explain, you can either pass explain output or query pg stats table with the stat system table. It is quite reliable, but a bit outdated if your analyze runs not so often. And the last one, what to do if you are slow in typing queries. You can write group by one instead of group by column name. You can write group by true instead of having count more than 0. And you can use MySQL and you will face no problems with normalized data aggregation. Any questions?
Are you recommending MySQL?
It's up to you.
From your numbers about the comparison about the C function SQL.
Yep.
It looks to me the C function is the approach which gives more constant numbers. Maybe it doesn't scale very well, large numbers, but it gives you constant performance. So how would you advise to use this approach instead of sticking to the classic SQL approach?
I have never used them on production, to be honest.
So it works.
It works. It works very well, but maybe you will need them if you use some custom types or so on.
That's good.
Let's try. If we need something like ArgMax, we will use this implementation. Yep.
If numeric is like a bar chart equivalent of the big int kind of thing, we know what happens when you go from a chart to a bar chart in terms of the performance when you try to do like sequential scans and stuff. Obviously, you get the benefits of being able to squash your data, but you get a lot of performance losses when you start using a bar chart. So if you were to use numeric instead of big int, obviously I can see how you get some optimizations, but would you not have to run into the same counter performance problems with numeric?
See, numeric is not so large in storage. It can occupy 3 bytes only when it is 0.
Because it's not a fixed width.
It's not a fixed width, but for small numbers, it is small. It's yeah, it's three bytes for small ones and then I think something like 4 bytes for each group of 4 digits or something like this. So
Okay.
it's not dramatically less.
It's not completely variable. It's actually kind of byte-based.
By 4 or by 8 bytes.
Okay.
Anyway, if you have enough zeros in the table, your space used will decrease, not increase.
But yeah, I was thinking of query performance. Yeah.
Still thinking about numeric. I remember that numeric is exact type, right?
Yes, it is exact. It supports fraction values, but they are just as you write. They are just like decimal.
Mm-hmm. So what if we sacrifice the precision and store just an amount of cycles, whether it's the number of zeros after the how is the storage? Can be improved if we sacrifice the precision?
Sorry. Do you mean that we should
truncating in some way the number to, for example, the last 2 decimal digits?
Yep.
It will spare us the space and then improve our
Yes, but it will be an approximate solution.
But sometimes maybe.
Maybe, yes, yes, maybe. True. Any more questions? Okay, feel free to contact me.
Good. Thank you very much.
A bit faster.